Okay, so we're still trying to figure out how to do the simple harmonic motion thing, but we're taking a bit of an aside to figure out what the derivative of inverse sine is. So we're assuming that you've defined inverse sine. Okay. So in particular, you know that, for example, sine of inverse sine of x is equal to x. Okay, and then we're also assuming, the chain rule. And that you know the derivative of sine is cos and some basic trig identities. Okay? Okay, so... So basically, anytime you have sort of this inverse function relation, you know one of the derivatives, you can find the other one.
Yeah.
But there's just a specific case of that. Okay, so what we can do is we'll start with differentiating both sides of this with respect to x. So the right hand side is easy. You just get 1, right? When you differentiate the left side with respect to x, this is where this chain rule applies. Okay, so you pretend it's just sine of x. So it'll be cosine of inverse sine x, right? Times the derivative of inverse sine x. So that's the thing we're trying to find, Okay, so this is the thing we want. Maybe we call it, z or something, So then, the thing we actually want, okay, z is equal to z of x 1 over cosine of sine inverse. X, right? Okay, so then just a matter of figuring out what cosine of sine inverse of x is. But we know that, for example, we know that cosine squared of sine inverse of x plus sine squared of sine inverse of x is equal to 1. Okay, and then this is just sine of sine inverse of x all squared. Right, that's what this notation means. But this is just x squared. Okay. So then we have that the thing that we want squared plus x squared equals 1. Okay. So just rearranging this will give you the cosine of sine inverse of x is equal to the square root, or plus or minus the square root, and it has to be continuous for 1 minus x squared, right? So that makes our final z of x equal to 1 over plus or minus the square root of 1 minus x squared. Yeah?
Yeah.
Okay, and we might actually be able to figure out what the plus or minus is as well, if we wanted to.
So how did you get it 1 over that?
Oh, because this was 1 over. See, we have the 1 over from before. So we put this now on the bottom. To distinguish between the 1 over, maybe we could actually just look at the graph. So the graph looks like this, right?
That's inverse sine.
That's inverse sine, yeah. And the slope seems to be always positive, It's always pointing up.
It's always increasing.
Yeah. Okay, so might not be increasing as much over here, but it seems to always be increasing, right? So it would suggest it should be the plus and not the minus, yeah? So that takes care of the plus and minus.
Right. It's always going to be increasing.
Yep. Okay, great. So then I guess the next step is to sort of, if the derivative of inverse sine is this, right, then that means the antiderivative of this is equal to inverse sine of x. Okay? And that's sort of basically what we want, except we have sort of an alpha squared or another constant here. But we can really deal with this. Maybe it'd be a nice exercise to try before we show you how to do it. Yeah?
So how to get the alpha?
Yeah, how to do it if it's alpha instead of 1.